Hey guys, Mr. Sarabian here, and we're going to continue our examination with geology in a little bit of a very special demonstration that I put together. That's the reason why I actually have not one, but two cameras set up.
Hi guys.
So, what is it that we are talking about this time around? Well, what we're going to be talking about is the rock cycle. Now, I have literally been spending this last week trying to come up with the right demonstration. And for some reason, nothing that I was looking up was working. Because here's the thing. When we're talking about the rock cycle, we're talking about how one type of rock can turn into another type of rock. Now, just to really kind of take a step back for a second, when we're talking about rocks, it's any substance found in the earth that is made up of minerals. And of course, minerals are made up of crystals, and crystals are made up of atoms. So that's how it kind of all links together. But as we also recall, we learned that we could put rocks into three different categories: igneous, sedimentary, and metamorphic. And how one rock turns into the other is what we call the rock cycle. But here's the thing. Mr. Sarabian was really racking his brain trying to figure out ways to make something look really cool for you guys. And, well, let's just say it didn't go very well.
My social media pages like Facebook, Instagram, and Twitter because I have fun news updates, behind the scenes, and even nice giveaways. Just search for my name, Libby.
Ooh, damn. It's like burning. It's like...
Oh, yeah. Get that off.
Yeah. So instead, Mr. Sarabian is going back to an oldie but a goodie. Clay. Now, you might be saying to yourself, how in the world do clay simulate rocks? Well, let's put it this way. After this is all over, maybe you'll see. So let's first start off with the basics. If you recall, we can break up rocks into three different categories: igneous, sedimentary, and metamorphic. Now, how we classify rocks is not based on their colors, it's not based on their hardness, it's not based on their streaks, it's not based on their colors, it's not based on any of those things. Because the problem is, rocks can come in a wide array of all of those different things. So we actually classify rocks based on how they are formed. So let's first start off with igneous rocks. Now, if we were going to be looking at an igneous rock in the form of clay, we have to first think about what are those different categories of igneous rocks. Well, we have extrusive igneous rocks and we have intrusive igneous rocks. Now, just to quickly recap, an intrusive igneous rock basically means that it's a rock that was cooled under the earth. Because remember, all igneous rocks form because of cooling magma. But it's just a matter of where is it cooled. If it's cooled inside of the earth, or if it's an intrusive igneous rock, it's cooled very slowly. So you can see really cool crystals form. So when you look at something like quartz, quartz is a type of intrusive igneous rock because you can see the crystals. Now, if you compare that to an extrusive igneous rock, you're going to see something a lot different. You're going to find things like obsidian. You're going to find things like scoria. You're going to find things like pumice. These are igneous rocks that are formed very, very fast. So fast that no crystals get the chance to form. So if you take a standard igneous rock like obsidian and compare it to this piece of clay, you actually see something pretty similar. You don't see any crystals, you see one solid color, and you see something that's basically straight up as it is. So, if we're looking at an igneous rock, we're looking at something like this, okay? And once again, igneous rocks are formed by the cooling of liquid rock. Okay? So now, let's say that you wanted to turn an igneous rock into a sedimentary rock. What do? Well, here's the thing. Sedimentary rocks are some of my favorite rocks, but they actually undergo a very complicated process. So let's start at the very beginning. First of all, what is a sedimentary rock? Well, keep in mind that a sedimentary rock is formed by the compaction and cementation of sediments. Now, whoa, hold on. Let's slow down for a second here. There were 3 big words that I gave you right from the very get-go, so let's make sure we clarify. First of all, what exactly are sediments? Well, to put it quite bluntly, sediments are really teeny tiny broken pieces of rock. So let's say that I took another igneous rock, okay, the blue clay. What do we mean by turning them into sediments? Well, the first thing that we have to do is we have to turn this big rock into a whole bunch of little rocks, okay? So all we have to do is either add things like wind or rain or ice or bad weather, hammers, chisels, all kinds of things that could break up rocks and turn those into sediments. Now, to really play up the difference, I'm going to get a red rock so you can also see that as well. So what we're actually doing is when we're talking about breaking apart an igneous rock or any rock into smaller pieces, we call it weathering. And weathering is simply a fancy term for the breaking of rocks. So, to get to a sedimentary rock, we first have to undergo weathering, which is, once again, the breaking apart of rocks into teeny tiny little sediments. So, that's the first step, okay? But now, where do we go from there? Seems pretty straightforward, right? Well, this is where things get a little bit more interesting. Because after a sedimentary rock is weathered and broken up into smaller sediments, whether it be sand, whether it be pebbles, whether it be clay, or whether it be cobbles, or whether it be boulders, they break apart into smaller, tiny pieces. So now, after they're broken into smaller, teeny, tiny pieces, they undergo what is called erosion. And usually when it comes to sediments, they go traveling off to a different location. Okay? And as they travel, that is what we call erosion. So, how am I going to simulate erosion here? Well, put quite simply, all I'm going to do is just jostle them up, like this. Almost like an earthquake here, guys. So now, we have eroded these sediments. But now, what happens next? Well, the next step that they go through is what we call deposition. And deposition is basically where they're placed somewhere. So, done. Really very, very simple, right? Deposition, just place them in one spot and you're done. Now, after deposition occurs, we now actually have to turn it into a sedimentary rock. So how do we do that? Well, you go up through a process which is called cementation, where they literally squish together. They cement together, they compact together, and now you have a sedimentary rock. So what's really awesome about this is that you still retain some of the original sediments that you see from the original rock. So some examples of these are things like conglomerate, sandstone, or breccia. Now, these are what we call clastic sedimentary rocks because these were pure, full-blown sediments of other rocks. You also have bioclastic, you also have chemical or crystalline, but we're just going to be focusing on these right now. Bioclastic is basically the same process, but you're crushing up with something that's organic, so shells or anything like that, okay? So now we have created a sedimentary rock much like that of conglomerate. It's actually pretty amazing how close they look. So, to create our sedimentary rock, we had to go through weathering, erosion, deposition, compaction, and cementation. When you put all 5 of those steps together, you then get your sedimentary rock. So now comes the big epic question. We have igneous rocks. We have sedimentary rocks. How do we get metamorphic rocks? Well, a metamorphic rock is formed by taking either an igneous rock or a sedimentary rock and adding so much heat to it that it recrystallizes. It literally turns from one rock into another with completely brand new colors and completely brand new properties. So, metamorphic rocks, recrystallized sedimentary rocks, or igneous. But how does that happen? How does recrystallization take place? Well, the key thing, honestly, is nothing more than heat and pressure. Or in this case, heat or pressure. Because there's actually 2 types of metamorphosis. And of course, the word metamorphosis means to change. So there's 2 different ways that a rock, either an igneous rock or a sedimentary rock, can turn into a metamorphic rock. You either have contact metamorphism, where literally the heat is directly added to the rock, or it happens in a regional metamorphosis, where it's actually pressure. So in this case, with our sedimentary rock, I'm going to add both heat and pressure. But what am I going to use? What am I going to use to try to add heat and pressure to this rock in order to change into a metamorphic rock? Well, nothing more than my hands. Now, you might be saying to yourself, how? Well, let's put it this way. I can generate pressure when I push my hands together. I can also generate heat when I rub my hands together. Plus, we're already naturally warm because we're a standard 98.6 degrees. So, we have heat, we have pressure. Let's take this sedimentary rock and let's turn it into a metamorphic rock. So, whether you want to look at it as regional metamorphism or contact metamorphism, doesn't matter. Now, let's morph. We're twisting it, we're rolling it, mat it, pat it, roll it, twist it, squish it, mold it, twist it, roll it, pull it, push it together, wheel it all around, add that heat, add that pressure, 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 add that heat, add that pressure. And now, what do we have? We have this. All of a sudden, those individual sediments have now become swirls and molds and twists, all in different arrangements and all different sorts of colors, and now brand new colors. We see this in the type of metamorphic rock that we love to use for tabletops, marble. Marble is a gorgeous example of a metamorphic rock because it looks almost identical to this. So, when you add heat and pressure, you take your sedimentary rock and turn it into a metamorphic rock. But now the big question is, how do you take a metamorphic rock and turn it back into an igneous rock? Well, much like the process of metamorphosis, you also need heat and pressure, but you need a lot more heat and pressure. So much heat and pressure that the rock itself actually melts. Yes, I know it may sound strange, but rocks melt. And let's put it this way. Where do we get lava from? Lava is liquid rock. So we have to add so much heat to this rock that it literally has to turn back into a liquid and basically no crystals forming whatsoever. So, can I do that? Of course I can. Mr. Sarabian can produce a lot of heat. So, how do we do that? Well, once again, twist that rock. Twist it, squish it, mat it, pat it, roll it, twist it, rip it, roll it, break it apart. Heat it up with your hands. Heat it up, heat it up. Let's see that. Roll it, squish it, kind of press it together. Add that heat, add that pressure. Twist it, squish it, roll it, pull it, mat it, squish it. Roll it in your hands back and forth. Get it real hot, melt that sucker down so this way it looks just like lava. All of a sudden, the crystals are now gone. You now have a much softer igneous rock. We'll add this back. And look at that, ladies and gentlemen. Because we have melting, we now have turned our metamorphic rock back into an igneous rock. Now, I know what you might be saying. Is this a one-way street? Does it only go igneous, sedimentary, metamorphic, and then back to igneous again? Absolutely not. The process can go in reverse. Now, I already used my blue and red Play-Doh, so let's actually mix it up a little bit more, and let's actually get some different colors into the mix. So let's say that I have another sedimentary rock, okay? Can that become an igneous rock? Of course it can. What do we need to add? That's right. We need to add so much heat and so much pressure that it literally skips over the metamorphic state and goes straight over to the igneous state. We have our sedimentary rock, right? Let's start melting this sucker, twisting it, rolling it, adding that heat. I'm rubbing it in my hands. I'm getting it liquefied. I'm twisting it around, and I'm melting it down to its basic elements. All those crystals that were there are now gone, and voila. We have now gone back to a straight up igneous rock. And all I had to do to bring it back to an igneous rock is to get it melting. But now, let's say that I have a metamorphic rock. Can I turn that into a sedimentary rock? Of course you can. All you need to do first is go through those 5 steps. First, break them apart into sediments. So I have sediments of this original metamorphic rock, and I'll join them together with sediments of maybe a few other igneous rocks, or maybe a few other sedimentary rocks too. After we have our sediments together, we weathered them down, and now we erode them. Shake it up in our hands, shake it up in our hands, shake it up in our hands. Then we deposit them. Put them in one spot. Now we add compaction and cementation. Whoop, and out pops another sedimentary rock. Complete with orange sediments, green sediments, and those sediments of the original metamorphic rock. So, through that same exact process that we underwent last time, weathering, erosion, deposition, cementation, and compaction, or I should really say compaction and cementation separately since compaction comes first, we get a metamorphic rock back into a sedimentary rock. But now, can we turn an igneous rock into a metamorphic rock? Of course we can. We start off with our solid igneous rock that has been cooled. So maybe it's obsidian, maybe it's granite, whatever it might be. And then we add more heat and pressure. So we twist it, we roll it, we squish it, we roll it, we mat it, we pat it, we squeeze it, we retwist it. Regional metamorphism or contact metamorphism doesn't make a difference. Because what do you get? You get another metamorphic rock. So, through the process of recrystallization, or basically heat and pressure, you can then get your metamorphic rock back. Something very simple, but something really cool as well. So, this is also something that's very, very easy. If anybody has any clay at home, I highly recommend doing this. This is actually a great way to see how one type of rock can become another type of rock. So, as you were watching, I'm hoping that you were filling in that sheet. But if you weren't, that's okay. All you got to do is rewind, go back to the beginning, and start again. So, this is Mr. Sarabian saying, stay healthy, stay safe.